Hello class, this is lesson 7-1 about graphing systems of equations. And what we're talking about is a set of two or more equations, and that makes a system. And so when you graph these equations, there could be different scenarios that you might find. For instance, if you graph the two lines and they intersect, then you are going to have one solution because you'll find that they are intersecting at one common point, and that would be x comma y. Now another scenario is if you graph the two lines, they could be parallel lines, meaning that they're not intersecting in any place, which means that there is no solution for that system of equations. The third scenario is if you graph one line and then you graph the second line and it's exactly on top of it, meaning it's the same line. That means that it has infinitely many solutions because they are intersecting in an infinite number of places. Other ways that we can describe these are the terms consistent and inconsistent. We would describe a system as being consistent if it has at least one point of intersection. So two lines that are intersecting, or even the same line intersecting with itself. Now, the system would be called inconsistent if it has no points of intersection, meaning that the two lines are parallel. We could also describe a system as being either independent or dependent. Now, the system is independent when the graphs intersect at exactly one point. And dependent is also going to be a consistent system, but it is where they are intersecting at an unlimited number of points, meaning that they are really the same line. So we're going to look at some equations now and what their graphs are, and we're going to graph each system to determine how many solutions it has, whether it is consistent or inconsistent, and then whether it is independent or dependent. So I'm going to graph my first line starting at +1. The slope is -3, so I'm going to go down 3 and to the right 1, and I'll connect those two dots. And then my second line is starting at -3, and the slope is 1, so I'm going to go up 1 and to the right 1 and connect those two dots. And now I can see that they are intersecting at one point, which means that this system has one solution, it is consistent, and it is also independent. So that's our first example. Let's look at our second example. I'm going to start at +2, and the slope is 1/2, so I'm going to go up 1 and over 2 and connect those two dots. My second equation is going to start at -1, and the slope is also 1/2, so I'm going to go up 1 and over 2 and connect those two dots. And as you can see, they are parallel lines, meaning that this system has no solution, and they are also inconsistent. Now, if the two lines are never intersecting, it can never be independent or dependent, so that's why we're not writing that for this example. Our third example, we have y equals 6x minus 4, and our second equation is 2y equals 12x minus 8. I'm going to rewrite this, so I'm going to divide everything by 2, and that leaves me with y is equal to 6x minus 4. So notice that's the same equation as my top equation. So I'm going to start at -4, and I'm going to go up 6 and over 1. And really, this is the same line graphed on top of itself. So it has infinitely many solutions. Also, it is consistent, but this time it is dependent. And we are done. Now, for the second half of this lesson, we're going to actually solve each system by graphing. So y equals -2x plus 4. I'm going to start at 4 and go down 2 and over 1 and draw my line. My second equation, I'm going to start at -4, and I'm going to go up 2 and over 1 and draw that line. And notice they are intersecting at the point 2, 0. So that is the solution for this system. All right, our next two equations are not written in slope-intercept form, so I'm going to rewrite them by subtracting 3x on both sides and then dividing everything by 5. So that leaves me with y is equal to negative 3/5 x plus 2. So I'm going to start at 2. I'm going to go down 3 and over 5. And then I'm going to go ahead and draw my line. My second equation, I'm going to rewrite it as well by subtracting x on both sides. And then I'm going to divide both sides by negative 5. When I do that, I am left with y equals positive 1/5 x plus 2. So again, I'm going to start at 2, and I'm going to go up 1 and over 5. And then I can see that they are both intersecting right there on the y-axis at 0, 2. All right, let's look at our final two equations. Again, these need to be rewritten. So let's add 3x to both sides. We're left with 2y equals 3x plus 12. I'm going to divide everything by 2. And now y is equal to 3/2 x plus 6. So I'm going to start at 6. And since I can't go up 3 and over 2, I'm going to go down 3 and backwards 2. And then my second equation, let's subtract 6x. We're left with negative 4y equals negative 6x plus 8. I divide everything by negative 4. And then y is equal to positive 3/2 x minus 2. So I'm going to start at negative 2 and go up 3 and over 2 and draw my line. And I have a set of parallel lines. So this has no solution for this system. All right, final example. Again, we need to rewrite. So let's subtract 3x on both sides. And we are left with negative y equals negative 3x minus 1. Divide everything by negative 1. And y equals positive 3x plus 1. So I start at 1, and I go up 3 and over 1. And I draw my line. And then let's rewrite this by adding 6x on both sides. Negative 2y equals 6x plus 10. Divide everything by negative 2. And y equals negative 3x minus 5. So I'll start down below at negative 5. But since I can't go down 3 and over 1, I'm going to go up 3 and backwards 1. And then I can go ahead and draw my line. And I can see that they are intersecting at one point right there at negative 1, negative 2. And I'm done. And that's today's lesson. So I hope that it made sense to you. But as always, if you have any questions, please see me in class.